Hello guys, welcome to my channel. This is the first video of my channel. Today I'm going to talk about this problem that was asked in June Circuit 2020 in Hackerearth. So the problem is number of triangles. It is the first problem of the challenge. So it is quite easy, but you have to think about it a little bit. So let's talk about it. So you are given a polygon of n sides with vertices numbered from 1 to n. Now we have given that exactly 2 of the vertices of the polygon are colored black and the remaining are colored white, and we have to find the number of triangles such that are formed with only white vertices into consideration. And the second condition is that the triangle should share at least one side with the polygon. Okay, so we are given t number of test cases, and n, b1, b2 are the input, and is the number of vertices. B is the vertex. b1 and b2 are the vertex number of the black colored vertices. So these are the constraints, as you can see, and this is a hexagon, this is the sample test case, and this is the output. Okay, so let's see how the output of this problem is for 2 and 5 are black colored. So I have redrawn this here. So I have redrawn this problem here. So 2 and 5 were black colored, so we first colored them black. This is black colored and this is also black colored. Okay, so the answer to the problem is for how is this. So first we will draw every possible triangle. So this is one triangle, 1, this is 2 triangle, 2, this is 3, and this is 4. So these are the 4 triangles that are. So let me redraw real quick. This is the first triangle, and this is the second triangle, this is the third triangle, and this is the fourth triangle. Okay, so these are the 4 triangles that are possible, so that's why the answer is 4. So let's break down the problem a little bit. Okay, so let's break down the problem. So we have said that we have to find the number of triangles possible with at least one side. So break down this at least into exactly 1 and exactly 2. One side and exactly 2 sides, and exactly one side okay, so exactly one side and exactly 2 side. So first we will see the part for exactly one side. Okay, so let me first clear these black holes, black color. So if we have exactly one side common, suppose that this is the side, if we have exactly one side common with the triangle, then how many triangles are possible? So let's see. Okay, so this is the first triangle and this is the second triangle in this case. So if we have total of n vertices, then we have already taken 2 vertices. If we have taken if we have n vertices, and we have already formed a side, so we have already taken 2 vertices out of it, so we are left with n minus 2 vertices. So out of this n minus 2 vertices, we cannot take these 2 vertices into consideration. Why? Because if we take this vertex, then we will also take this side into consideration. Then if we because we are considering the first case of exactly one side, then we will have exactly two side sharing with the polygon. So we cannot take either 3 or either 6 into consideration. So we have a total of n minus 4. We have total of n minus 4 sides left into consideration. Okay, so suppose that we have n minus 4 side. If there were no black colored vertices, then this would be our answer for this particular line. But this would be our answer for this particular line. But we have also given that we have black colored vertices, so we cannot take those. So if out of these n minus 4, if we have any of these vertices, then we will subtract those vertices from our answer. So if these two both are black, then this is our answer. If either of 3 and 6 is black, then n minus 5 will be our answer. Otherwise n minus 6 would be the answer for this particular edge. Similarly for this, similarly we will calculate for each and every vertex, each and every side of the polygon. So this was the consideration for exactly one side. Now let's take into account exactly two sides. So if we have exactly two sides, suppose this and this, then we can only form one triangle out of these two sides, because if you have fixed two sides of the triangle with a polygon, then the third side is also fixed. Because we cannot form a triangle with three sides touching with the sharing with the polygon, because it will form a quadrilateral. So there can be at most two sides sharing with the polygon. So how many triangles are possible? So there are total of n triangles possible. First, second, third, fourth, fifth and sixth. As you can see, if they are in this example we have 6 sides, so there are 6 triangles possible. Similarly, if we have n side, there would be n triangles possible. So now we have to only not take those sides which have those triangles which have any of the vertex as colored black. Okay, so this was the problem, and we will now sum up just sum up the both two answers. This would be our final answer, exactly one side and exactly two sides. Now we will see this into code. So this is our code. So the code is very simple. We have just taken the input number of test cases, and for every test case we are taking the R1 and R2 are the black colored edges, black colored vertices, and is the total number of vertices. So for every vertex 1, 2, 3, 4, 5 and 6, we are taking this also and this into consideration. Why, you will see. So let me just draw. So if I have taken this for I is equal to 1, this is for I is equal to 2, this for I is equal to 3, this. Okay, so if I is equal to 1, this, then this is first, this is second, then this is third. So first and second will form a triangle with only one side in common. and first, second and third will combinedly form with two sides in common. Then we have, so if, so first will be I, second will be I plus 1, third will be I plus 2. That's what I have done here. So if this second, this is greater than n, then second will be second minus n. Similarly, if this third is greater than n, then third will be third minus n. Why? Because if we have reached to this point, this is I equals 6, I equals n, so then the second will be this, third will be this, so this will be 7, this will be 8 according to this, but it should be 1 and 2, so this will be second minus n, third minus n. Now here we in this if loop, in this if condition, we are checking for one side in common, and in this if two side in common. Okay, so if neither of first, neither of second are there, neither of first, neither of second is colored black, then we can definitely form a triangle. Okay, so now I have previously said that we have to also consider side previous, vertex previous to this. So the vertex, so the vertex previous to this is this, and the vertex next to this is this. That's what I have calculated in the prev and third. So this is the third, this is prev. Okay, so if these are colored black, means this is equal to R1 or R2, and third is equal to R1 R2. I am saying that if both are colored as black, then n minus 4 will be the total vertices in consideration for this site. Okay, so if any one of them is colored black, then n minus 5 would be the answer, and and in the else case n minus 6 would be the answer. This was the one side in common. Now for two side in common, none of the vertices, means first should not be colored black, second should not be colored black, and third should not be colored black. If so, then we can only form one triangle out of them, and this would lead to one increment in the answer. Now in the end, we just output our total answer. So this was the explanation of this problem. I hope you enjoyed the video. Like and share the video and subscribe to my channel. So thank you.